Yeah, it's always easy for us to start something as just apply a force and make a driveway, the particle will start moving. We have seen many cases in which we are starting a motion. What about stopping? What about stopping a particle? We have to learn that one also because it is the motion which we created or motion which is created have to be under control. So we should know how to stop. What are the requirements for stopping a particle? So this is a session of virtual classes of Scientia in which we are going to discuss the distance required for stopping a particle, or we call it as the stopping distance. That's why I have written stop on the board. So we are going to see the stopping distance. What is meant by stopping distance and what are the different aspects? And we will try to solve a couple of questions also, so that it will be very easy for us to understand the problem. Just take a case of a car which is moving, a car which is moving, say with a velocity of 30 meters per second. The car was moving with a velocity of 30 meters per second. And the problem, it is given that the brakes can be applied and the brakes can offer a retardation of say maximum 10 meter per second square. It's retardation, so I can put negative. Problem is how much distance the car will take to come to a halt, or how much distance will it cover before it is coming to stop. That is a problem of what? Stopping distance. It's a typical problem of stopping distance. So let me draw the situation. What I have got is, I've got a car which was moving initially with a velocity of 30 meter per second. It is coming to halt. V is equal to 0. I have to find the distance taken or distance covered by the particle through which it was experiencing a retardation of 10 meter per second square. Stopping distance. So the S can be called as what? The stopping distance. We can solve this problem in two ways, or we can take the aspects of two aspects. One is the first way of solving the problem. I'll say this is just by using one of the equations of motion that we know. So the first method of finding out stopping distance is using equations of motion. So like we have three equations of motion, and look at the board. VUSA, which will be convenient for you. We can instantly say that this will be the most convenient expression or most suitable expression for us, because here all the parameters are known except the S, which is the problem which we are doing, because our aim is to get the stopping distance. Remember, all of you, this kind of questions are very common in many entrance exams even. So this is a problem because we have got V square is equal to U square plus 2AS. So stopping means what? Final velocity of the particle is equal to 0. And for stopping, what is required? A have to be negative. So the stopping means V is equal to 0 and A is equal to negative. So substituting, I'll get 0 is equal to U square minus 2AS. Rearrange this, I'll get 2AS is equal to U square. Or the stopping distance is given as S is equal to U square divided by 2a. This is the expression for stopping distance. So we can say, if in some problems, if a is given as a constant, we can choose this expression. S is proportional to u square. S is proportional to u square. So that means for constantly accelerated particles, the stopping distance depends only on the square of the initial velocity. Stopping distance depends only on square of the initial velocity. So the problem is clear, and it is clearly done with the help of equations of motion. This is the most simplest manner to find out the stopping distance. I will use that one and I will solve the problem for you. So what are the things which we know? We got u is equal to 30 meter per second, v is equal to 0, a is equal to 10. Let me substitute that one over here. We have stopping distance is equal to u square divided by 2a. What is u square? U square is 30 square. 30 square is 900 and acceleration is 10, so 2 into 10. Solving this, you will get the value as 45 meters. So the stopping distance for that car is equal to 45 meters. This is one method of doing the problem with the help of equations of motion. Now, for those who can extend their studies into the concepts of work and energy, they can do this problem in other manner. So I will show that one also for you to get the same expression for stopping distance by using work energy principle. Second method is to do the problem with the help of work energy principle. Work energy principle. What is work energy principle? The work done is equal to change in energy. You can express that one in terms of kinetic as well as in terms of potential. I will use the expression the work done is equal to change in kinetic energy. So work done can be expressed as final kinetic energy minus initial kinetic energy. We must have studied this is also equal to what? Initial potential minus final potential energy. So here this is not useful for us because we are not dealing with stationary system. We are dealing with particles which are moving, or we are studying motion. So we will use W is equal to, or work done is equal to K2 minus K1. That is final kinetic energy minus initial kinetic energy. Now look into the same problem. Suppose I am assuming that the particle has got a mass m and it has got an initial velocity u. Let me take the initial kinetic energy as k1 and final kinetic energy as k2. When there was an acceleration or a retardation like this, we can assume if there is a mass m, there is a force acting in this direction. So my situation can be depicted like this. Initially this was having k1, finally this was having k2. When there is a force acting in the backward direction, or there is a retarding force acting through when a displacement S is taking place. This is the problem. So what is work done over here? Work done can be written as force dot displacement is equal to initial kinetic energy. For that I can write initial kinetic energy is equal to half mu square. Initial kinetic energy is half m into initial velocity square. And what about final kinetic energy? Final kinetic energy is 0 because it is coming to rest. So this becomes 0 minus half mu square. That is my expression. So I have got minus half mu square is equal to F dot S. F dot S. What is F dot S? F is towards my left and S is towards my right. So F and S are making how much degree? how much angle between them? F and S makes 180 degree, or they are opposite. F dot S is making, F and S are making 180 degree. F dot S can be written as Fs cos theta. And this cos theta in this case is equal to minus 1. Cos theta is minus 1 when the theta is equal to 180 degree. So F dot S or Fs cos theta becomes minus Fs. So the left hand side becomes minus Fs, which is equal to minus half mu square. What is force? Force is mass into acceleration, which is equal to minus half mu square. M and m gets cancelled. Negative and negative cancels. We get S is equal to u square by 2a, just as the same type of expression which we have got using which one? The equations of motion. So that is another method, or that is another illustration of work energy principle when we are discussing the stopping distance. You can see the work energy principle is satisfied in this problem. Okay, let us extend our studies or understanding of the stopping distance with the help of another couple of questions. Okay, so let me take a second problem. So this we have got the stopping distance expression as S is equal to u square divided by 2a. Now, second problem which I am going to do for you. This is for you to see, always it is preferable to solve as many numerical or as many concept type of problems when you study a new concept. Okay, here I am giving you two conditions. A car which was initially moving with say 40 km per hour is brought into rest in 8 meters by applying brakes. So this is my first situation. Situation 1 is a car which was moving with a 40 km per hour brought into rest in 8 meters by applying brakes. Suppose the same car was moving, situation 2, suppose the same car was moving with the initial speed of 80 km per hour, how much distance will it take to stop by applying brakes? All other conditions are the same. So this is our situation. We have to find S for another initial speed. What I can do is, I'll take this one as S1 case, this one as S2 case, or situation 2. I have got this expression, S is equal to u square by 2a. Both the cases, brakes are applied. That means we can assume that force acting was the same or acceleration is constant. When acceleration is constant, stopping distance, we know that S is proportional to u square. Problem becomes very simple now. First situation divided by second situation is equal to u1 square divided by u2 square. First situation is proportional to u1 square, second situation is proportional to u2 square. So S1 is already given as 8, this is S1, this is u1, this is S2, this is u2. Substitute here, S1 is 8 divided by S2, u1 square is 40 square divided by 80 square. 8 divided by S2, this can be written as 40 into 40 divided by 80 into 80. Simple to solve, you will get 4 in the denominator. S2 will be equal to 4 into 8, 32 meters. So we have seen how to do a problem when there is a comparison between two situations of the same particle or same car or same system. Now let us extend this one using another problem. See, this is our second problem. Now a third problem. I will give you one more question. Problem is like this. The speed of a car is reduced to, say, 3 by 5th of its initial value. The speed of the car is reduced to 3 by 5th of its initial value. What will happen for the stopping distance? What will happen for stopping distance? That means initial speed is reduced to 3 by 5th of the initial value. We can formulate two situations. Same car, we know that acceleration is constant. What we can do? We can use the same idea which we have applied for the last problem. We know S is proportional to U square. Initially, suppose the value was U. Now final value is 3 by 5th of U. So U1, let it be equal to U. So U2 is equal to 3 by 5 of U. S1, let it be S. We have to find S2. You can do it very simply right now. Say S2 by S1 is equal to 3 by 5 the whole square U square divided by U square. 3 by 5, that is 9 by 25. This is 9 divided by 25. So S2 becomes 9 by 25 times the initial value. So when the initial velocity reduces to 3 by 5th of the initial value, stopping distance reduces by 9 by 25 times the initial value. So this is a clear understanding of how to stop a particle. You have to know how to stop a particle, or the control should be there with the driver or who is dealing with the problem. So you are the driver. You have to keep your car or system under your control. Thank you very much for watching this session of virtual classes of science. Thank you.